So in this section, we're going to check when verifying trig identities if it's going to be the same on both sides. So before, we always worked on the complicated side and see if it equals to the other side. So in this example, we have cosine x over secant of x minus 1 equal cotangent square x times 1 plus sine x. So typically we're going to work with the fraction side, the most complicated side. So whenever we have a fraction with a denominator of secant x minus 1, what I'm going to do is multiply by the conjugate, secant of x plus 1. So on the top, we have cosine x times secant x plus 1 over secant of x minus 1 in parentheses times secant of x plus 1 also in parentheses. So at this point, all I'm going to do is going to distribute the cosine to the secant and the 1 inside the parentheses. But on the bottom, we're going to FOIL. So secant x to secant x, and then secant x to 1. Don't forget about the negative 1 to secant x, and negative 1 to 1. So here we have to FOIL. So after distributing cosine x, I'm going to have cosine x secant x plus cosine x over secant square x minus 1. Now you're going to get this after you fully FOIL combine like terms, and what you have left is secant square x minus 1. Next, I'm going to leave the numerator the same, but secant square x minus 1, I can actually use the Pythagorean identity. When I work out the specific Pythagorean identity, the only thing that I can replace it with is tangent square x. So at the moment we have cosine x, secant x, plus cosine x, all over tangent square x. Now, at the moment it doesn't look like we can do anything. So the next step to make our work easier is to convert everything into sine and cosine. So I'm going to leave the cosine the same. What I'm going to do to the secant of x, I'm going to apply the reciprocal identity, 1 over cosine of x, and then plus cosine x over, and then I'm going to apply the quotient identity for tangent square x, which will be sine square x over cosine square x. Alright, I'm going to erase this side to make more room. Alright, so we have cosine x times 1 over cosine x, and then plus cosine x over sine square x over cosine square x. Now, the first thing that we can do to simplify is distribute this cosine x to the numerator. Remember, cosine x is like a whole number, just multiply it to the numerator. So, we're going to have cosine x divided by cosine x, and then everything else stays the same. But we can simplify cosine x divided by cosine x. That will simply become 1 and then plus cosine of x over sine square of x over cosine square of x. Now, there's nothing else I can do in the numerator, which is fine. But in our denominator, we have sine square x over cosine square x. So when you have something that is being divided by a fraction, we can rewrite it as a division of fraction. Now, before I could do that, I double check the numerator. I have 2 parts. So since I have more than one part, I'm going to put it in parentheses. Just like that. Now I'm going to rewrite it as a division of fraction. 1 plus cosine of x divided by sine square x over cosine square x. Then I'm going to change it to multiplication. So the first part stays the same. Multiplication, and then I'm going to flip the second fraction. So cosine square x over sine square x. Alright. So again, the first part stays the same. Nothing I can do to simplify. Now here, I can apply an identity to simplify this fraction. So that way we don't have fraction in our answer. I'm going to apply the quotient identity. So for cosine square x over sine square x, the quotient identity for this one is cotangent square x. Now I'm going to double check with the right side. Now it says that the right side was supposed to equal to cotangent square x times 1 plus sine x. Now I see that we both have cotangent square x, but the only thing different inside the parenthesis is the cosine x and the sine x on both sides. Now we know we have that 1 on the left side, we have cosine x, and on the right side we have sine x. So that means that they're not the same on both sides. So when we verify, the left side was supposed to equal to cotangent square x times 1 plus sine x, which it didn't happen. We end up with cosine x. So what we're going to do is just write not equal, and then I'm just going to write QED. So when you see that the left side is not the same as the right side, or the right side is not the same as the left side, then just simply say not equal QED. Now, if you want to double check you did your work correctly, then just mess around with the right side. And if you're unsure how to mess around, it's always best to convert it into sine and cosine, and then see if you can manipulate it, multiply, distribute, add, subtract, and see if it matches up with the work that you did for the other side. So again, if you want to double check your work, make sure that when you verify you did everything correctly, carefully. And if you want to see if that maybe you should do something to the other side, go ahead, distribute, add, subtract, divide. Just make sure you do it carefully, and it's always easier to convert it into sine and cosine to see if both sides are equal. After you try your best and it doesn't, then you just write not equal QED. In our second example, we have cotangent square x minus cosine square x times cosecant square x minus 1. And it's supposed to equal cosine x. So that means we're going to try to convert the left side, which is the most complicated side, into the right side. Now, before I can do any kind of work, I need to take a look at this one right here. So cosecant square x minus 1. I see there's a trig function as square and as some 1. So, especially when it's cosecant square x with a minus 1, that means I can apply a Pythagorean identity. Using the correct identity, rearranging it to match with this cosecant square x minus 1, this be switched out or replaced with a simpler term, cotangent square x. So I'm going to rewrite it. Everything would stay the same except for the ones in parentheses. Now, instead of cosecant square x minus 1, I'm going to switch it with cotangent square x. Now, you can include parentheses, but you don't have to. Alright, now looking at this, I have cotangent square x minus cosine square x cotangent square x. I notice that in these two parts, which I'm going to underline, that they have a common factor, which is cotangent square x. So, what I'm going to do is I'm going to factor out the common factor. When I'm factoring out, I'm dividing. So, cotangent square x, cotangent square x. So when I'm factoring, these common factor doesn't disappear or go away. It will simply be outside of the parenthesis. So my first part that comes after the parenthesis is this cotangent square x divided by cotangent square x, which is 1, minus cosine square x cotangent square x divided by cotangent square x. The only thing that's left is cosine square x because these factors divide into 1. And I'm left with cosine square x. Close parenthesis. Alright. Now, it seems like I can't do anything else. And of course, the best option was to rewrite everything into sine and cosine. But before I can do that, I need to double check if I can apply something or work with this 1 minus cosine square x. So as I'm reviewing, the cosine is square and then there's a 1. So that means maybe I can apply a Pythagorean identity, which I can. So using the correct identity and rearranging it to match with 1 minus cosine square x, the only thing that can be replaced is with sine square x. So cotangent square x will stay the same, and then it will be switched out. The 1 minus cosine square x will be switched out with sine square x. Now, there's nothing else I can do at that point, so then it's okay to change everything into sine and cosine. So here, cotangent square x, the only thing I can use the identity to have in sine and cosine is the quotient identity. So cotangent square x will be rewritten as cosine square x over sine square x. Now I put in parentheses because it's a fraction multiplying to sine square x. So we have this fraction multiplied to sine x. So sine x is like a whole number, so you're just going to simply multiply to the numerator. So I'm going to write it up here. Cosine square x sine square x over sine square x. Now my two trig functions are multiplying, so when I'm trying to simplify this, I can divide common factors, one from the top, so one sine square x from the top, and then one sine square x from the bottom. So that means the only thing I have left is cosine square x. And then that's the only thing I could do, and there's pretty much it for the left side. Let's see if it matches with the right side. The right side is cosine x. So, taking a look, the left side will simplify all the way to cosine square x, but the right side is simply cosine x. So, if I double check my work and mess around with the right side, cosine x, the only thing I can do to it is apply the reciprocal identity, but that's not going to get me anywhere. I can't apply the Pythagorean identity, I can't apply the quotient identity, there's no other identities I can apply, so there's not much I can do to double check the right side. And after I double check my work, see if everything was correct, I did it carefully, the only thing left is these sides are not equal. Now, even though they both have the same function, cosine, cosine on both sides, on the left side it's square, on the right side it's not. So, in order to be the same, they have to have the same exponent. So, if it was square on the left, it has to be square on the right. If there was no exponent, meaning just a power of 1, just like the right side, then the left side should have the same exponent as the right side, cosine x, which in this case it's not. So it's not equal on both sides, and I'm going to write QED saying that I'm finished with my work.